So what is the Archimedes Principle? Well, the Archimedes Principle states that an object submerged in a fluid will have an upward force exerted on it by that fluid. This is called the buoyant force. And the buoyant force is equal to the mass of the fluid displaced. If the buoyant force is equal to the force of gravity, the object will only partially be submerged in the water and will not sink. However, if the object is heavy enough, the force of gravity will be greater than the buoyant force and will have a net force, and that will cause the object to sink. So let's just do a quick experiment. So we have 3 balls. Each of them are made of the same substance. The only difference is the volume the ball takes. So which ball do you think is going to have the greatest buoyant force acting on it? Do you think the largest ball is going to have the greatest buoyant force, the medium-sized ball, the smallest ball, or do you think they're all going to have the same force acting on them? So let's merge them. As we can see, the ball with the greatest volume caused the greatest displacement of water. And the buoyant force is equal to the mass of the fluid displaced. If we have more fluid displaced, it obviously has a greater mass, so that means there's a greater buoyant force acting on that object. Another important thing to get from this is that if an object is completely submerged in water, or any fluid for that matter, its volume is going to be equal to the volume of the fluid displaced. Okay, so we're just going to do a quick problem. We're going to say we have a mass with a density of 10 cubic centimeters, and it's hanging from a string that's connected to a scale that weighs 1,000 kilograms while the mass is in air. And then we completely submerge the mass in water. What is the buoyant force on the mass when this happens? And also, what is the scale going to read? And to do this, we're going to assume that the string has no mass. The density of water is 997 kilograms per meter cubed, and that the acceleration of gravity is 9.8 meters per second. So to do this, we're first going to have to figure out the buoyant force on it. And as we know, the buoyant force is equal to the mass of the liquid displaced. And we also know that for an object completely submerged in a liquid, its volume is going to be equal to the volume of the liquid displaced. So all we're going to have to do is take the volume of our weight and multiply it by the density of water to get the mass of the water displaced. 1 times 10 to the negative 5 meters cubed times 997. And that'll just be equal to 9.97 times 10 to the negative third. And that's in newtons. So we have our buoyant force is 9.97 times 10 to the negative third newtons. And that's pretty small, so it's not going to have that big of an impact on it. And so then we're going to find out what the scale reads. And to do that, we're just going to draw a little diagram with our 2 forces. There's my buoyant force, which is 9.97 times 10 to the negative third. And there's my force of gravity, which is much bigger. And it's equal to G times our mass, which is equal to 9.8 times 1,000 kilograms, which gives us 9,800 kilograms. And then we're just going to find the net force, which is just the difference between those two. So 98,000 minus 9.97 times 10 to the negative third, which is going to be equal to 9,799.99 newtons. And then to find out what the mass reading is, we're just going to divide that by 9.8. And we're going to get that our mass reading is going to be 999.99. And if we rounded correctly, it would actually still come out to 1,000 kilograms. So the buoyant force on this object is relatively small and doesn't have that great of an impact, but there is a force and there is an impact nonetheless.